So the last thing we're going to do with sine and cosine is to actually reverse the whole process. We're going to write an equation given a graph. So we're going to jump into the first. We've got two examples here, and then the rest of the problems on here will be part of the key. Ask any questions that you have, but I'm not going to do a video on those. So what would help is to identify some key features. So your maximum here is this horizontal line, y equals 2. Your minimum is this horizontal line, y equals -4. Oops, let me go ahead and make that y equals. There we go. Now, the midline is going to be literally the middle of those. A couple things you could do. You could count the spaces between them, divide it in half, and then count your midline that way. Or you can take the two values that you have, your maximum and minimum, add them together and get the average. So that's what I'm going to tend to do. So 2 plus -4 is -2. But the average then would be to divide by 2. So -2 divided by 2 gives me a midline of -1. And so that midline is actually my vertical shift. So down 1. Because normally the midline for either sine or cosine is the x-axis, and clearly we've shifted it down. Now, one way to double check your midline is actually to work with the amplitude. So if I count from this midline to the maximum and this midline to the minimum, I should have the same value. So from -1, 1, 2, 3 units up, so I should have an amplitude of 3, but just to double check, 1, 2, 3, make sure you're counting it correctly. So amplitude is 3. And the period, for this, what you want to do is basically find a starting point and an ending point. And what I'll do for a lot of these is I will actually draw one cycle of either the sine or the cosine curve. Now, almost all the time, I'm going to start on the y-axis. And in this case, my y-axis is on, my graph is on the midline. And so if I were to graph this, this one cycle is one cycle of the sine curve. Sine curve starts on the midline. It increases or decreases depending on your reflections. But in this case, it's increasing, decreasing, then back to the midline. So the period in this case is going to be from 0 to 4 pi. So let's go ahead and mark the period as 4 pi. Now, what I'm going to do with that period is I am going to set up 2 pi over b. Remember, b is the coefficient in the equation for x. So I want to solve for that. So 2 pi over b is equal to 4 pi, and then solve for b. So I'm going to cross multiply here. So 2 pi equals 4 pi b, divide both sides by 4 pi. Let me zoom in so you can see this a little bit better. And then I just canceled out the 4 pi and 4 pi. So in this, the left side, the pi's will cancel, and 2 over 4 becomes 1/2. So now I know that coefficient for my equation is 1/2. All right, let's go ahead and see if we can't put this all together. So this green shaded graph, because it's starting on the y-axis, there's no phase shift involved at all. So I'm just going to go ahead and say this is what it is. It's the sine graph. So I'm going to go ahead and write myself a sine equation. Now, it has to be an equation, so make it equal to something. Sine, cosine, I'm trying to think if there's any exceptions to this. No, they're going to be functions, so you can use f of x. If you don't want to use that, just use y. So sine is equal to, or f of x is equal to. Now, sorry about that. My amplitude is 3, so we're going to do 3 sine. Now I want to pull this coefficient for x, so 1/2 x. No phase shift, so I can go ahead and close the parentheses. And then my vertical shift was down 1, so I'm going to do -1. That is my handy-dandy sine equation. Now, somehow I need to find a cosine equation for this exact same graph. So for cosine, you want to find a maximum or a minimum point. And by the way, sine and cosine curves, if you haven't figured it out, I'm going to just outright tell it to you. There's an infinite number of sine graphs or sine equations that will give you the exact same graph, because you can always do phase shifts off of itself to create the same exact graph. Cosine and sine are the same curve. They're just phase shifts of each other. So they're literally offsets. So for cosine, you want to find your maximum or your minimum. It won't matter which one. So I'm going to randomly pick, and I'm just going to pick this minimum right here. So here's my minimum. And then my cosine curve would basically be one cycle here to here. Now, period didn't change. I know it looks different, but from negative pi to 3 pi is the same period of 4 pi. So that hasn't changed. We still have the same maximum, still have the same minimum. The midline hasn't changed. The vertical shift hasn't changed. But what has changed, and there's two things here. First thing that's changed is this cosine equation has a phase shift, and the one that we picked, or the one that I picked, is left. That's the negative. So left pi. The second thing is this particular one that I picked, because I started with a low point, a minimum value, this is actually a reflection of cosine. So if you start with a minimum value, you need to use a reflection, all right? So for cosine here, I'm going to do f of x equals, I'm going to throw the reflection in place, so negative 3. Amplitude didn't change. We're going to do cosine. Now, to make this work, you need to be very careful how you write this. We're going to do the coefficient of 1/2. And then in parentheses, we're going to do x, in this case, deal with the phase shift here. So left pi is actually going to be plus pi units. And then let's see if I can fit this in here, minus 1. So if I were to graph these two equations, the sine equation and the cosine equation I just wrote, both of them should give me this exact same curve. That's the whole point of what we're working on here. So find one equation, should be able to do it with an amplitude, period, and vertical shift. And then the other one is going to be a phase shift off of it. And just be careful if you need a reflection, and definitely be careful when you do this multiplication, because that coefficient needs to be out front, and then the x plus the phase shift or minus the phase shift in parentheses. All right, so that is example number 1. I'm going to go ahead and slide down to number 2 here. All right, so problem number 2. Let's get a minimum. Let's get a maximum. So maximum here is at 5. Minimum here is at negative 3. So maximum y equals 5. Minimum y equals negative 3. Halfway between 5 and negative 3. Do the average of them. So 5 plus negative 3 is 2. Divided by 2 is 1. So midline is y equals 1. So there's my midline. That midline also tells me my vertical shift would be up 1. The midline to the maximum or the midline to the minimum is going to be my amplitude. So 1, 2, 3, 4, 1, 2, 3, 4. Yep, double check it. So amplitude is 4. Period. So I'm going to find where my curve crosses the y-axis. In this case, it's down here at this minimum. And in this case, since I'm at a minimum, I'm going to go ahead and say I'm dealing with a cosine curve. So up to the maximum, back down to the minimum. And that's going to help me figure out and see visually what the period is. Because these graphs are periodic and they just continue forever, you only want to look at one cycle for the period. So the period in this case is pi. So to figure out what my coefficient is, I'm going to do 2 pi over b equals my current period. I'm going to zoom in on that. Cross multiply. So 2 pi equals b pi, b equals 2. So that's going to be the coefficient for my equations, and that's going to be for both sine or cosine. Now, for this particular curve, I've already got one cosine cycle highlighted, so I'm going to go ahead and use that one. Keep in mind there's no phase shift here, but there is a reflection since we're starting low. So my cosine equation is going to be f of x equals negative, amplitude is 4, cosine of my b values, so 2x, and vertical shift of up 1. All right. Now that I've got the cosine curve, I need a sine curve. For the sine curve, find your midline and pick a point on the midline. Now you'll notice there's lots of points on the midline. It doesn't matter which one you pick. So I'm going to go ahead and pick this first one right here and just graph one quick cycle of the sine function. So sine function starts in this case on center. However, it's moving in the positive direction. So it's increasing. So that means it's positive. If you had a sine curve, let's say you picked, let me pick this orange color. If you had picked this point right here and then started drawing your sine curve, this is a decreasing function here. So that would be a negative, so it would be reflection over the x-axis. So be careful when you write these. There's lots and lots of options. Just pick one and go with it, but just make sure you actually are paying attention to all the pieces. So for that sine equation, we have a phase shift of, now, it's not labeled here, but this is literally halfway between 0 and pi over 2. So that's going to be a phase shift right pi over 4. Now, on a test or anything like that, I'll make sure that the it's very obvious what the phase shifts are, so that you're not guessing. Just be aware of that. Okay, so my sine equation here, f of x is equal to, amplitude is 4, and this was a positive, so it's starting at the midline and going up, so that's positive. So it's going to be sine. Now I want to do 2, which will get me the period of pi, but I need to do x minus pi over 4 to get the phase shift, and then plus 1. All right, that is a horrible one. Let me try that again. Slightly better. All right. Now, all of this work up here is to help you actually get these answers right down here. So I'm going to go ahead and slide on down to just show you when you're on the actual practice problems, it doesn't specifically say to find the amplitude, period, vertical shift. Find those pieces though, so that you can write the equations. All right. So examples 1 and 2 are done. The other problems, you clearly just saw a few of them. The other problems are done on the key. Also, if you are concerned and you're like, hey, I picked this as mine and you're not sure, throw 2 equations in Desmos and see if you get the same curve. All right. You can always do stuff like that and see if it works. If you are unsure and you just want to double check with me, feel free to send me send me a screenshot and say, this is my example, or this is the problem. These are the equations I got. Did I do it right? And I will definitely let you know. All right. I hope this has helped to figure out how to change from a graph to an equation with sine and cosine.